Welcome back to the Bash Security Challenge. Day 4, and we are covering loops. Yesterday was conditionals, making decisions. Today is about repeating those decisions across hundreds of targets, thousands of log lines, and dozens of ports. If conditionals are the brain, loops are the legs. Let us get into it. Starting with the for loop. The most basic form iterates over a list. In security work, that list is usually ports, IP addresses, or host names. Say you have an array of common ports, 22, 80, 443, 3306, 8080. You write for port in, then reference the array with $sign curly brace ports at sign curly brace. Inside the loop body, you can use Bash's built-in TCP pseudo-device to test each port. Echo to dev TCP target port. If it succeeds, the port is open. Wrap the echo in a subshell so a failure does not kill your script. One important detail: always quote your array expansion. Without quotes, any entry with spaces would split into separate words. With port numbers that does not matter, but build the habit now because it will save you when iterating over file names later. Now let us talk about C-style for loops. Double parentheses, a counter variable, an increment. This is perfect for scanning IP ranges. For I equals 1, I less than or equal to 254, I++. Inside the loop, ping the target subnet.I. But here is the thing, running 254 pings sequentially with a 1-second timeout takes over 4 minutes. That is painfully slow. So we background each ping with an ampersand. Now they all run concurrently. But you need to call wait after the loop to pause until all background jobs finish. Otherwise your script will exit before results come back. You can also throttle by calling wait every 50 iterations to avoid spawning too many processes at once. The while loop is your tool for processing input line by line. The pattern is while red -r variable, do something, done. The -r flag prevents / interpretation, which you almost always want. Feed input with redirection, done < file name. Here is where we hit the most common bash loop bug. If you pipe into a while loop, cat file pipe while red, the loop runs in a subshell. Any variables you set inside the loop disappear when the loop ends. Your counters stay at 0. Your arrays stay empty. I have seen experienced engineers waste hours on this. The fix is process substitution. Instead of piping, write done <= open paren command close paren. This feeds the command output into the loop without creating a subshell for the loop body. Variables persist. Problem solved. Let me show you a real use case. Say you are parsing a CSV export from a vulnerability scanner. Each line has IP, port, severity, and plugin name. Set IFS to comma just for the read command so it splits on commas. Use a case statement inside the loop to count critical and high findings. Feed the file with process substitution and use tail-n+2 to skip the CSV header row. After the loop, your critical and high counters have the correct values because no subshell was involved. This is a pattern you will use constantly when processing scan results, log extracts, or asset inventories. The until loop is the inverse of while, it runs until the condition becomes true. It fits monitoring scenarios naturally. After you patch a service and restart it, you want to wait until it responds to health checks again. Write until curl-s-f the health endpoint. Inside the loop, sleep 5 seconds and increment an elapsed counter. Add a timeout check so you do not wait forever. When curl finally succeeds, the loop exits and you know the service is back. In real incident response, wrapping this in a script with Slack or email notification is genuinely useful. Quick hits on loop control. Break exits the loop immediately. Break 2 exits 2 levels of nesting, handy when you have a hosts loop containing a ports loop and you want to bail on both. Continue skips to the next iteration. Use it to skip unreachable hosts early without indenting the rest of your loop. Body inside an if block. And when iterating over files, never parse ls output. Use find with -print0 and read-d empty string. Null delimiters handle every possible filename correctly because null is the only character that cannot appear in a Unix path. That is loops. For iterating lists, while processing streams, until monitoring conditions. Tomorrow we take these patterns and wrap them into reusable functions. See you on day 5.